All right. So, just going to make sure that we have all the good indicators here, that everything is streaming properly. So give me a minute here, and we will get started with the this informal update of Android 10's internals. Alrighty. So, much like in the other live streams that I have done, I have a few people who are joining us through a private channel, and quite a few were likely joining live on YouTube. So depending on where you send your questions, I'll just repeat them out for everyone's benefit in case there are, people that aren't on the proper channel. So good morning, good afternoon, and good evening wherever you are. My name is Kareem Yagmor, and in this next, hour or so, or maybe shorter, I don't know, we'll go through the internals of Android 10, at least what I've been able to peruse kind of rapidly by doing some quick comparisons with, quick comparisons between Android 10 and Android 9. So this is not a definitive sort of internals overview. Over the next few months and such, probably I would actually go through and kind of delve a lot deeper into the 10 version to see what is new in greater detail. So yeah, the slides will be up a bit later today or tomorrow. Just give it some time. I will actually put the link for the whenever I put them up there, I will put the link in the YouTube video, so you can actually grab it from there once it's over. So if you're not familiar with my work, I wrote the Embedded Linux book for Riley in early 2000s, the Embedded Android book for them about 10 years ago, and I've been involved in Linux and open source for about 25 and some years. And you can go find my name in the kernel sources here and there, or at least once, until my stuff gets removed. And so when I'm not doing these lectures or classes, I'm helping customers putting Android on all sorts of weird devices. Okay, so what do I want to talk to you about today? So I want to go over a bit, generally speaking, what's been added across all parts of the stack. So I'm going to do a quick architecture recap, but if you've seen some of my other presentations, which I know are out there, you've probably seen this material before, so I don't want to spend too much time on this. But I do want to actually highlight where I think some of the changes that we'll see later fit. And then what I'll do is I'll run you through lists I've kind of put together based on the changes that I've seen between, again, 9 and 10, and possibly also go to the shell and show you around what I've been able to find in the systems themselves. So I'm using here the emulator as my primary target. But I could have used a real device. Obviously, then I would have needed to possibly have, say, 2 identical Pixel devices at hand, or some other dev board that ran both 9 and 10. Okay, so really quickly here, this is the architecture of Android. Nothing new here. If you want to have more details about that, go look at my other videos. So we got the Linux kernel here at the bottom, a bunch of native components right on top. Then we have the Java world and some applications on the top there. Nothing has changed in terms of architecture from that sense. There have been sprinkled additions a bit all over the place. If there is one single addition that I should say, kind of permeates kind of like across this and has some more in-depth architectural impact, I would say that that's probably the Apex stuff they've added. So this has impacts a bit across the stack here. And in summary, the Apex mechanism seems to be a way to update dynamically some of the core system components without actually going through an OTA. So that will allow us to, for example, update some libraries down there and possibly some system components in the core. It remains to be seen where it goes in the future. I have a few thoughts about that later on that I'll share. So we'll talk about Apex, but generally speaking, so for example, in comparison to between 7 and 8, when they introduced Heidel and Treble, which kind of had fundamental changes to the core, I'm not seeing this sort of change in 10, aside from, as I said, the Apex bit. Okay, so of course, Google has an official list of the things that they announce as being part of new in 10. You can go take a look at that. So on the developer site, and if I just let me just click here quite quickly on this one. Nope, not this way. So my slide system behaves differently on my computer than the rest of the computers. So okay, let's open this in a new tab. Okay, so if you go here, you'll see they've got some security enhancements, connectivity features, and so on and so forth. And those really are feature lists for application developers. They're interesting. Obviously, they are certainly things that you want to take a look at. But from my perspective, I'm never quite satisfied looking at this. I want to know what's going on underneath the hood, and so this sort of information is kind of scratching the surface, but doesn't satisfy me with regards to what's going on inside of Android. So just to give you kind of like a really big overall comparison of AOSP 10 versus AOSP 9, and this is just really quickly here on building an emulator for both versions and comparing those together. I'm not mentioning it here on the slide, so the target being built here is AOSP x86-64 ENG. So obviously the size has grown a bit. The build times have grown on my machine, so this is kind of like the configuration I've got. The only thing that's odd about my system is I'm actually using full disk encryption on it, so that's probably slowing down my builds a bit. I haven't actually timed the difference, but whatever. In my case, I actually have to do that for all sorts of other reasons. So anyway, that being what it is, I have here about a 50% increase on build times, and this is a pretty decent machine. So this is something that I'm not sure. We'll see with 11 what happens. Maybe I need to at that point update my system when I get to that. The output size, for some reason, in my case, has diminished. I don't know if there's something maybe weird that I did in my version 9 there. I would not kind of like generally expect that to be this in this configuration. But anyway, the system service sizes. This is one number that I personally use as a kind of a general idea of how many changes or how substantial the changes were in the system services. So we've got here, about 130,000 lines of code that have been added to the Java System Service. And in case you're wondering what that number corresponds to, I usually just go under framework-based services and then follow the path for the bulk of the Java System Services, which are core Java, Android, blah blah blah, and then just do a cat of all the Java files and do a word count of -l to see the number of lines in those. So it's not a super kind of scientific measure, but it gives me an idea from one version to the next. And I believe the previous version was 330 or something like that, or 300 something. So we're gradually increasing here the complexity of the system services, which is not unnatural for an operating system that is evolving over time. Okay. The changes of interest, at least the ones that kind of caught my eye. That doesn't mean there isn't anything else that has to be looked at, but those are the ones that on a first pass kind of were of interest to me to explore further. There are certainly other changes which are more, say, internal in terms of algorithms being used and things like that. I didn't get to that level. I think that would be kind of like a second or possibly third pass. If I was investigating one specific area of the system, I would then start digging into that in more in-depth fashion. But for the moment being, just the looking at the just looking for information about what I can gather by doing simple comparisons at a superficial level. This is what I'm seeing. So Apex, which I mentioned earlier, and I'll get back to that later on. There's about 30 new system services. I believe some of those are just rearrangement of existing things. So it's not like these are necessarily totally new. Some of them are for sure. There are some changes to the init semantics, or maybe I should say rather additions. So they've added a few things to init to make sure that there are some additional capabilities for example, for Apex. And there's some debugging capabilities that have been added for helping in debugging the startup of initial services. There's some new HMM commands, not too bad, actually kind of useful. Not something radical, but interesting enough. I think I'll be using that in the future. There seems to be the additions of the BPF and BCC stuff. I've seen quite a few things land their way into the AOSP, and I'll point those out as I go along. And there has been some moving around and redefinition of some things that we'll see along the way. Okay, so in terms of system services, so what I did just basically here, let me show you actually what I did on my system. Going here to my shell, let me just actually make this a bit more friendly for viewing. Oops, sorry. Okay, and now that I did that, I just switched. There we go. Okay, so I've got two. Okay, let me do this. Let me make this a bit bigger. Okay. Oh, there we go. This is the sort of thing that is to be expected. So I've got two versions of Android trying to run the emulator. So actually, you'll notice here that I've got one emulator right here. Forget the display. It's okay. There it is. It came back. Anyway, so go back home somewhere around here, possibly. Oop! Now it died. Alrighty, let's start this guy over again. So yeah, that's one emulator. The other emulator is 9.x. So I've the idea is to have them both side by side, and they're gonna be competing a bit here on the EDB front. So don't worry too much about that. I had it working not too bad earlier. EDB shell, if I can get that to work again. Devices. Let's see. Actually, I'll just go ahead and do this. So ADB-S emulator 5554, and eventually they settle down. It may die still yet, but good enough. Anyway, so yeah, that's what I was saying. What I did is just a service list on both sides. So I did a service list on Android 10, and I went into Android 9, which I have around here, another shell somewhere. Give me a second. I think this is the guy. There it is. And let me actually also set this one to the same sort of scheme. All right. Actually, let me not use that ADB. Let me use the ADB from 10, because otherwise we're going to get into some more trouble. All right, making sure we're going to use the same ADB on both sides. So now let's shell into the other guy, emulator. No? Or died? Let's see if it's still alive. Or I got a typo then. No, I don't have a typo and he doesn't connect. I'll just restart in that case. Give me 1 second. For some reason, I was able to do it here. Oh, yes, I'm sorry. Being distracted this morning. There you go. Okay, anyway. So this is just a check proc version. All right, yes. This 4.4 actually is being used by 9, whereas if you look at 10, it's using, at least for the emulator we're talking about here, right? It's using 4.14. So this has been kind of like my quick way of finding out which one I was running on. So anyway, I did a service list on this side as well, and it just compared both sides. And if you do that, you end up with a list such as the one that I got here on my slide. So, you know, activity task, ADB, Apex service, most importantly, you know, bug report and so on. So this here, for example, bug report dump state, I assume that they just kind of recast the dump state stuff into as a system service instead of it being kind of like a daemon that in the past, I believe, used a Unix domain socket or something like that. Ashmem here, which is now a system service, so possibly this is being used instead of you know, dev ashmem or whatever it is. So what else do we got here that caught my eye? DNS resolver. This one I want to look at. I want to see what this does a bit later. GSI service. So generic system image. I want to see what this does. I'm not exactly sure what this actually does at this point. Rollback service. I believe this has to do with the file system rollback stuff that they've been working on. Stats, test harness, and so on. Suspend control. So this here apparently some sort of way to control the system suspend for hibernation. Yes. As somebody aptly noted on the chat of YouTube, shell command. I had completely missed that. Thank you, sir. Okay. Right. So the Apex service has an AIDL file that we can go take a look at a bit later. Some of these things I'm not exactly sure what they do, like app prediction. I have to look at that, what does in more detail. So anyway, just to take a look at some of these things. So if I go, for example, looking for the Apex services AIDL, we'll find that down into, let me see here, not this, but rather that other monitor. So I'm just going to go grab Emacs. There we go. So if I go looking at system, Apex, ApexD, AIDL, Android, Apex, I have here my iApex service. So if you want to know what Apex provides you, then you can take a look at this, you know, and effectively understand which Apex files are, you know, like talk about Apex files, or like see which ones are active, you know, activate some, and so on and so forth. So that's for the Apex service definitions. I haven't looked at the ADB definition. I'm curious as to, you know, why this has gotten wrapped into some form of AIDL interface. I presume that maybe if I go underneath daemon here, I may be able to maybe not find the AIDL file. Actually, let me do a quick find for that if I can get my hands on it. You know, and as I said, this is a bit informal here. I'm trying to just you know, share with you what I've been able to find, and at the same time kind of think aloud about the things that I would actually go around and explore if I was actually doing this on my own, like full, you know, looking into the comparison between the two things here. So system, core, ADB, and if I do a find --name star AIDL, no, it doesn't seem to be here. So I don't know where this is hiding. It'd be interesting to look at. Obviously, you know, if you've looked at some of the stuff, you know, before me, or you know the answers to this stuff, feel free to share. in the chat there. I'm happy to repeat what people have found out loud. So this is for kind of like exploring system services. So this would be kind of like my first thing that I would do on a new version of Android, regardless of what it was. I would shell into there and do a service list. Obviously in this case, there are 167 versus 130 in 9. So I wouldn't parse through the 167, but I would try to do a comparison between the two, see which ones have been added, and then try to figure out the relative importance of each one of those. And then at the next stage, I'd go looking for the EIDL file of each of those things, and possibly some README documentation if there is some in the sources. Sometimes they do a fairly good job of explaining what it is that they were trying to do in a system service or another, or maybe it's even exposed to app developers. In that case, you've got plenty of documentation because then they have to explain it to application developers. But sometimes it's kind of like a bit mysterious. You kind of look at something and there's little to no comments, and you kind of have to, think a bit or possibly have some inside track information to understand, okay, that's what this thing does. One thing that I was interested to see here is input flanger. So this is actually new because usually it's the input layer of Linux that is used directly. So I'm not sure whether that means we've got some other stuff underneath it or not. It'd be interesting to see. In fact, yes, yes, there is. So there is an input HIDL underneath there. So it'd be interesting to see what's in that, and whether they decided that they didn't want to necessarily rely on the input layer of Linux. Because if my memory serves me right, when last time I checked this, like several Android versions ago, Android assumed that we had the input layer of Linux. So this would seem to indicate that they're kind of like possibly abstracting that away and kind of using a generic sort of interface for all input, and then possibly this is linked to Linux's input stuff, but may not actually be linked to it. So the other thing I would do usually is also look at the HIDL directory at a top level. So obviously I haven't looked under the existing directories to see if there's new sorts of hardware. So if you look in the camera, for example, there are several subdirectories underneath the camera HIDL. And when I'm saying here top level directories, the directory I'm looking at is hardware interfaces. So if you go on hardware interfaces, there are several directories in there, and some of those have several subdirectories. I haven't looked at the subdirectories, just did a first pass at the top level. So if you go here underneath the, other screen, switching over here, going all the way to the tab under hardware. So if you go in interfaces, interfaces, and atrace 1.0. So atrace is the utility that is used for, or at least was used for tracing. Now it seems that they've decided to have a sort of HIDL interface for it, which list categories and enable categories. These were actually commands that you could actually pass to the atrace command tool, and now they seem to actually be exposed as a HIDL interface. So I haven't explored who's using that yet. So that's for atrace. The second one I spotted was fastboot. So if I go here under fastboot 1.0, iFastboot HAL. So this is actually for talking to the bootloader. You can see here, get partition type, do OEM command, get variant. So this probably has to do with some of the dynamic partitioning stuff that they've been thinking about, that they have talked about at some public forums. Like if you go back to the Linux Plumbers Conference of last year in Vancouver, there was a presentation about this. So this might be useful to this sort of stuff, but I haven't investigated this at any depth. Then we got the input layer. So if I go up here, looking at input, and so let's go for common, and this is just the types. Okay, classifier. Not exactly sure what this is. Classifier, current input events, reset device. Okay, so yeah, I'm not clear as to what this the purpose of this interface is yet. This is something that I'll have to look at in more in-depth fashion. Not sure whether I'm not seeing anything here that allows us to abstract the input layer that Linux has. So this is just classifying current sequence of inputs. It's not even actually getting the inputs from here. So, or providing some sort of registration functions for getting them. So, okay, to be explored. All right, that's input. Pre-built hashes. I'm not exactly sure what the purpose of that would be, but let's go take a quick look at pre-built hashes. No, actually, these are just. Oh, okay. So this is not new interfaces. This is just the I guess pre-built hashes of the chain of the HIDL interfaces themselves. Okay, so this is not actually new interfaces. I should correct that. So these are not new HIDLs. Now, when you do an ls-hal, this is another thing that I would do in comparing to two versions of Android. So if I go here in 9 or 10, this is 10, so I do it ls-hal. So this is going to give me the hals that are seen by the system. And if I want to do the same thing with 9, again, another ls-hal on this side. And then if you run a comparison on those two things, what you'll find is, so this camera service 2.0, this one seems new. So some of them are not actually hardware, like HIDL interfaces, but with frameworks instead of being hardware. This is something that requires a bit more kind of like digging to understand exactly what they're trying to do with that. Some of these are just variants, like some stuff that has been added that is newly defined. Again, this is from running on the emulator, so it is possible that the definitions were there before, but the daemon might not have been actually running. So for example, thermal is a HIDL type that existed in 9, but now we're actually seeing in the emulator that they're actually running those as default. So, give or take, this stuff might not be necessarily new from the stack, but it's just showing up as new on my on running my my emulator instance. Okay, the root file system. So this is just kind of like exploring the root FS, just doing ADB shell and then exploring what's around. And so just quick pass here. You do a ls-al on one side, and for the life of me, I don't understand why this is not enabled by default. But anyway, so I just use the color variant because I want to see. Some color coding. This is 9, okay? So this is version 9, what we have for the emulator. And if I do the same thing here for 10, -al -color. So you'll notice here that we've got this apex thing that has appeared. There's a few more things here, like product services, which is a symbolic link actually out to system. And what else did I spot here? Debug RAM disk and res. Res, I think I had seen in the recovery RAM disk, if my memory serves me right in the past. With regards to Apex, this is the top level Apex directory is the so again, color /apex, and so these are the actual directories which are being used for Apex purposes, and we'll get back to that a bit later. But if you look at some of these things, for example, let's look at runtime. So com Android runtime. So this would be kind of like in this case bin. So this is effectively your art stuff. So you can see here that I've got actual binaries here under this com Android runtime, and you'll see that for every one of these entries under the Apex, let's go again with that. There is a version with there's a version number directory and one that doesn't have a version number, and they are effectively the paths being used are supposed to be the hard-coded paths, which are which are going to point back to one of these version numbers wherever they are. So right now there's only one version that's installed here on the system, but it's not entirely impossible to have multiple versions, and then they'll just update on top of each other. The latest version being the one that's going to be actually used. So that's for the Apex directory here at the top level. Now if you start digging a bit deeper, you'll see that Apex has things in a bunch of different places. So I have under system, I've got Apex as well, and under data as well, I've got Apex bits. So if I go here under, let's do this, of system Apex. So these are the Apex files that will have come effectively from factory, you know, directly from so to speak, you know, the manufacturer, and presumably under data Apex, I should have my packages which are updated. I mean, ultimately, Apex files are, yeah, there's like nothing that's been kind of updated on the system because they're all coming from /system. So presumably, the Apex files are effectively kind of like APKs. So you can actually use a lot of the tools that are used for manipulating APKs to actually look at Apex files. Okay, there's some other stuff here that I haven't had the chance to explore, like data GSI. So I presume this has to do with the generic system image things, and there is nothing here of, you know, obvious significance that I can, you know, kind of share with you any sort of understanding of. So this is one that I'd have to spend a bit more time to explore. There's a local prop file that I found under data. So this is not necessarily new. I think that the init process already knew to look for a local prop file if one existed, and in the past it's not actually been used. This is the first time I see it in the emulator, but I think it's not something that's necessarily new with version 10. Then some rollback stuff under data, and some other directories that I would actually take the time to explore a bit more. Okay, so one general thing that I'll recommend also that you try when you're going from one version to the next is, if you want to try to understand what's being done during the initialization process, is just a very basic diff between the old version and the new version of the init.rc file. So in this case, let me show you what I get if I do that. Let me just grab a proper shell that has this. Okay, so this is 9. So let's do this. Let's do a diff of system core root dir init.rc. And if I compare that to, so let's go for Android 10, which is in my case over here, AOSP 10, system core root dir init.rc, right? So this is always a bit entertaining, trying to see what it is that changed in the init.rc file. And some of it is just kind of like housekeeping, so I'm not going to spend too much time on it, but sometimes it can be kind of interesting to see what they're doing. There's some noise here of some stuff that I added myself, so you might find some customizations that I have done in some cases, but you know, most of it is exactly as it was. So there were some things in here that caught my eye, namely, so what we have is, okay, further down I think here, this is, so you can see here, this is the Apex stuff that that's being done here, so making some directories and then effectively starting Apex D. And then we've got further down here, let's see some main, start boot animation. Yeah, I think the main thing that had caught my eye really was the Apex stuff that we saw there. Yeah, and yeah, parse Apex. There's a bunch of Apex things that have been added here. Now that's one thing. So that's just kind of like a general, kind of like FYI. They have added a few options to the semantics of the service declarations and the commands. So one thing that I would do is something like this. So alongside that, what I could do is something like use meld. So let's use meld. I should have used meld for this as well, but anyway. If you're not familiar with meld, you'll appreciate the output of this. So let's compare system core, and then init let's grab the README file, and also same thing with here. Whoa. All right, let's go for init README file, and let's open this up. Okay, so meld, by the way, if you're not familiar with it, just kind of gives me a side-by-side view, a comparison, sort of diff, visual diff between those two things. And so you can follow effectively what was added left and right. Some of this is rearrangement, so it's not necessarily new, like capabilities in class I think was just rearranged, so they're like coming from below, and they seem to have just put this stuff in alphabetical order, so ignore those. What's interesting here, so interface, that I haven't seen this before. Associates the service with a list of idle services that it provides. That's new for me. IO priority I had seen before. I mean, interfaces might all be old, but I can't remember seeing it before. Override. So override, actually, yeah, there we go. Indicates that this service definition is meant to override the previous definition for a service with the same name. So this actually is for Apex purposes, and I think it's mentioned in the Apex documentation. Priority I don't think is new. Six stop. Yeah, six stop is interesting. So this six stop thing is super cool for debugging, and they have actually some documentation further below as to how this can be used. I'll show you that. Updatable also is for Apex services, to mark the service as being updatable. This start post data, class recess post data, this is new, this class start post data. I can't remember seeing this before, and there's further down something with that too as well. Mark post data, so effectively, you know, okay, now we've mounted slash data, you can go ahead. Parse Apex configs, and then further below to the complete end, towards the complete end, where's that one? Oh, that's a new property that's exposed. Anyway, this here is super cool. So, you know, they have actually some good comments here. So launching init services without init is not recommended, as init sets up a significant amount of environment, you know, blah, 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 that is hard to replicate manually. If it is required to debug services, then use effectively the option, which is six stop, and they now have some examples in there that show you how to actually use this. So you've got, you know, for example, if you want to debug log D, you can do a stop log D, and then control six stop on for log D, start log D, and then effectively here you're going to be able to use GDB to actually debug log D, or in this case they're using strace to do something similar. This is actually interesting because I know a lot of people had been struggling with, hey, how do I debug the starting of X, Y, or Z, and it's always a bit convoluted. So this is a welcome addition. At least I haven't seen this before. This seems brand new, and at least in the documentation, the README file seems to indicate that it is new as well. It's not unheard of though that the README file might contain some stuff that's actually not in the sources. That was the case a few years back when they had documentation on a device attachment, like on device or something like that, and the README said it had it, but the actual init code did not, and at some point the code actually was updated. So it's like the README was a design doc versus what was actually in the sources. So anyway, this sort of stuff is not unheard of. So those are the commands I mentioned, the debug stuff. Oh, processes. So another thing that you can randomly do to find out what's new with the version of Android that you're using is just a very basic PS. So go in here and do a PS on one side, or PS-A, and then you go in the other one and do a PS-A as well. The output is a bit hard to parse because effectively if you look closer at the list of processes that you've got, you have a whole bunch of kernel threads. I've ignored those. They're not relevant to my analysis. Then you have kind of like three sort of broad categories of stuff. You've got daemons, you've got hardware services, and then you've got actual applications. So if this is how I cut down my my analysis here. So new daemons, APEX-D, AshMemD. That one certainly I would explore a lot more. AshMemD I believe is attached to the new. This is probably, both of these are probably the system services that appear in the service list. Trace-D probably related to the tracing and BPF stuff that I mentioned. These HIDLs appear as being new, but again, thermal is not a new HIDL, so maybe this is just the fact that the emulator now has it built. And in terms of applications, you know, some some stuff which this one actually is, I think is curious. I'm not sure what that is, what they call here network stack. I'm curious as to what they mean by this. I have to look that up. So yeah, I mean, if you want to look for Apex, the daemon in the sources, it's under system. So under system Apex, you've got the Apex D that's there. Okay, now if you go looking in the AOSP sources itself and you start exploring the code base, obviously we're talking here about several gigabytes that have been added. So you know, there's probably untold number of man hours that could be put in analyzing the differences. And by the way, we've put up on our on our website, on our cross-referencing website, the change log for that. Let me actually show you here. Thank you, François, for taking care of this. So let me go here under xref, whatever random stuff it's displaying here, xref operators.com. Going here to this. So if you go here under the change log, it'll tell you the differences, say, between 900R48 and 1000R1. So the change sets here are pretty extensive. So you know what's been newly added components versus you know further down removed components. So what's new here? So if you look here at just the top level really quickly, you'll see that we've got some new devices like the Google Bonito, the Lenovo Poplar, and the TI BeagleBone X15. I believe this is the BeagleBone with the AI stuff on it. You know, and so on for some other stuff down there. I'll highlight some of those that caught my eye a bit more in a bit more detail. So again, if you go looking under the system directory, this is the stuff that jumps out. So the BPF stuff, this is certainly for probably for the BCC, BPF, dynamic instrumentation stuff that the kernel now has. If you're not familiar with that, Google eBPF. This is like one of the hot Linux topics these days. A lot of things are being looked at in being put into BPF. And if you're not familiar with that infrastructure, so BPF stands for Berkeley Packet Filter. And no, this does not actually have to do with networking. The idea is that the Berkeley packet filtering mechanism in the kernel has this sort of engine that is some sort of virtual machine. And they've repurposed this for all sorts of purposes, including tracing and instrumentation. So you can dynamically insert trace points and instrumentation points in the kernel to gather information about what's going on dynamically. This has been effectively godsend for a lot of people, because the kernel had previous to that abilities to add static instrumentation points and use K-probes, which is a bit raw in terms of an infrastructure for doing tracing. And if you had heard about, say, dtrace before, then the eBPF BCC stuff gives Linux similar, if not better, capabilities than what was there with the dtrace stuff. So what we're starting to see here in Android is these parts kind of starting to make their way into the AOSP. There's a bit here and there's a bit somewhere else. I'll show to you later on. So GSID, again, this goes probably with the GSI system service that I saw. I'm not sure what this does. I'd go explore that a bit more. If you go to external, there's quite a few things, and as usual, there's quite a few changes here. So I'll just point out the ones that caught my eye as well. And again, by the way, this slide section, much like the other ones, I highlighted the stuff that was added. I did not highlight the things that were removed. The cross-reference or change log that we posted has the details of what was removed. So BCC, that's for there's one missing here, I think, that I somehow forgot it in my slide, but it is in the sources. So let me see here. If I go under external, there's another one that I had noticed, which wasn't there before. So yeah, here it is. I should have added this to my slide. I'll just fix that after the video. So ADEB, ADEB stands for AeroDeb, and it's this package that was put together by Joel Fernandez, who's the maintainer of the BPF and tracing stuff in the Aero team. and effectively it allows you to load on the device under /data a sort of Android environment, a Debian environment in Android, so they can get the full Debianized shell, and that's used for the BPF and BCC tracing infrastructure. So that was not in 9 in as far as I can recall. Let me just double check here. It was something you could download additionally. Oh, I know. Does it show up here on my side? No, I don't have it here. It's not under external under 9. So no, I have used it in the past with 8.x, but not a 9. But it was a download, something I downloaded off of, I think, GitHub. But now it seems to be straight into the AOSP, and it just should be like on the top there. So that with BCC is for the BPF stuff. There are some things here that may have actually more meaning to you than myself. If this is an area of the stack that you're working with, so maybe those names will ring a bell for you. Some of the stuff doesn't ring a bell for me, so just kind of skipping over it. Lua, I assume this is the Lua interpreter, but I haven't looked at that. Min GBM, so generic buffer management infrastructure there. OpenSSH, that I'm surprised to see there. I can't recall SSH having been there in the AOSP before, but if you have seen that, let me know, but I can't recall OpenSSH having been there. OpenSSL had been there in the past, but not OpenSSH. U-boot, that's surprising. So some vendors have put U-boot under the bootloader directory because they were using it, but in here it is straight in the AOSP, and as far as I can recall, this is the first time I actually see U-boot, and I was kind of curious because this is a GPL package, and I went to see in there, and it seems to be the full U-boot. So I'm not exactly sure what the rationale for this being in there is. Is it because they need some of the tools that are there, or is it because they want to see people use it in their devices? Not totally clear. Okay, HMM. So if you run HMM, this is not new with 9, by the way. If I go here and I do a just like a plain HMM here. So HMM is like on the online help that gives you what's running. The commands that are available to you for working with the AOSP sources. So this is the stuff like lunch and so on, and MM and M and those things, and croot if you're familiar with those. So those here, the all mod, go mod and path mod and refresh mod, this is not something that I had seen before. So if I do an all mod here, it's going to tell me all the build modules that exist. So for example, if I want to see what variants of the launcher are here, I could do all mod grep-i launcher. No, it'll work if I actually don't do a typo. Launcher. So you can see here I've got launcher 3, plugin lib, and so all these things are kind of buildable. And if I do a path mod, sorry. Say path mod of launcher 3. So no, not patch mod, but path mod. There. So it tells me what is the path of that package to be built. So that's interesting as well. What else did I see in here? Okay. Let's going to Apex. So the idea here is to enable Android to have some of its core system components updated without doing a full OTA. The official documentation for this is actually in master. I haven't found that file actually in 10, but it was in master. So open a new tab. Let's go grab this. So here's the documentation for Apex, and so. When you're talking about updating operating system components, one of the first things that will come to mind is, wait a second, this has been done before. It's been done by multiple people across decades of time. So surely the variations or things that you can and can't do are known, and Android's going to adopt one of those. And nope, Android does its own thing. And so at the bottom of that README file, they actually have an explanation here of some of the stuff that they've looked at. So alternatives considered and rejected. So regular package management systems, they seem to actually not like this. And the rationale is not too bad. Actually, this makes sense. So, Linux distributions have package management system. However, they weren't adopted by Apex because they can't protect the package after installation. So the idea here is if we allow untethered installation of packages, then the problem is once a package is installed, there's no way to verify whether that has maintained its integrity. And so I guess this goes back to all the verified boot work they have been working on for years, and kind of makes sense, right? If you want to have a solid chain of trust from silicon all the way up to the application layer, then you have to guarantee every step of the way nothing has changed, and if it has changed, you have some trigger mechanism to tell you, oh, wait a second, something has changed there. So the regular package management, like if I'm using, say, I don't know, Ubuntu, and I'm installing a deb package, then once it's been installed, there's no way, so it is checked at installation time for signature, but once it's installed, if any of the modules or components are changed, there's no way to check that they have changed. So this I kind of get. Demcrypt, so effectively here, the idea is why not just install stuff in an encrypted directory and use that, and they make a good point here that by itself demcrypt is not a guarantee of integrity. So although this provides some level of protection against tampering, its primary purpose is privacy, not integrity. So in other words, the fact that you're using an encrypted file system doesn't actually guarantee you that nobody has actually tampered with your encrypted partition. And that holds true, that is true. So therefore, you can't just rely on the fact that it was encrypted to actually make sure that it hasn't changed. But I actually have a counter argument for that later on. So the idea here is you've got this, so the other thing is also they don't want to have paths redirected from system to Apex, take whatever system bin foobar and have system bin foobar now use /apex com blah 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 system bin foobar. The clients have to know that they're talking to Apex packages. So and clients here mean consumers of. At least that's the language being used here in the document is clients. So whoever uses a part of an Apex package has to use the path directly under Apex. At least that's my understanding as it stands at this moment in time. So it is based on an APK file, and that's actually going back all the way to the top of the file here. So you have an Android XML file that is actually used much like an APK tool. So with the APK tools, and then you have an image payload. And this is kind of like the other side of it. So effectively, the content of an Apex is a file system image. So they create a file system image, they put the content in there, and then they put that, zip it up in this file, and they ship that as an APK. Upon installation, when the package manager sees that this is an Apex, it hands it off to the Apex D and says, "Sorry, none of my business. It's yours to handle." And then the Apex daemon apparently just takes that and does its checking and installation stuff. And then upon reboot, the image is mounted on loopback and then appears under /apex. And then there's some bind mounting that is done to direct the actual Apex directory to the one that's been just updated. So they're walking you through the steps here. If you care to read this down there, they tell you, exactly what they're doing. So the package manager starts the procedure upon recognizing the files in Apex. The package manager transfers control to Apex manager. Apex does its thing, and then to continue the installation, the system automatically reboots the device. Upon reboot, the Apex manager reads the internal database, does the following for each Apex, verifies the Apex, creates a loop device from the Apex, creates a device manager block device on top of the loop device, mounts the device mapper block onto a unique path, for example, Apex name server, and so on. So that's generally speaking the Apex in a nutshell. And if you go down there further, the file is interesting because they actually give you an example of building an Apex, and you can find Apex examples that are provided in the AOSP. So that's for the Apex system, at a glance. There's a lot more to see there. It remains to be seen what the how they proceed forward with this. It seems from what I'm seeing in terms of packages that they have, because they actually have a where was I? I think I were. Let me see. Dumpsys Apex service. Is that what I did? Can't remember. Yeah, there we go. So here, for example, the packages which are apexed in this version. So Apex ETS Chim, Conscript, Media, Software Codecs, Resolve, Runtime, and Time Zone Data. So from what you can see there, these are fairly core things that vendors don't necessarily want to or have to customize. Like the runtime, well, that's art, so usually vendors don't have to touch that. Time zone data as well is probably universal to everybody, and so on. So those packages, if you follow kind of like try to extract some logic out of the pattern that's here, seem to be things that are so core to the system that most vendors don't necessarily have to touch them, and therefore there's a way for Google to say, okay, let us take care of this for you, and then this is apexed in the sense that we can now actually update those components independent of an actual OTA. So without actually doing a full OTA, we can go ahead and add these hooks for changing or updating these components. So where do they go with this in the future? It's not too clear to me. What is clear to me, though, is at least personally, I don't get the arguments against using a package management system, because if you go to this presentation at least, and then again I did what I didn't want to do, which is click on the other button. So sorry, give me 1 second. So there is a talk at least that was done in 2018 at FOSDEM about using the crypt setup tools to actually set up the Linux DM integrity edition. And so DM integrity ensures that your encrypted partitions have not actually been tampered with. And that would actually solve the integrity part of the equation for, I think at least personally, would solve the integrity issue associated with possibly using some sort of dynamically modifiable system partition, or dynamically modifiable partition that has binaries and stuff. If you look at, for example, the content of external, just to kind of take that as a reference. So if I do a ls-1 of external, so we've got about 300 packages under external, and if you count, if you look inside the AOSP itself, there are quite a few packages which most vendors don't actually have to play around with. And the Apex existence and list of packages that are there is a good example of that, because there's at least in this case about 10 that Google was able to identify that most vendors don't have to mess with, and so those two are probably candidates for packaging. So at some point in the future, TBD, I don't know when, I don't know how, but maybe there will be an interesting argument to be made for Android to actually move over to an actually full-fledged package management system, where you could package possibly all of these external stuff as packages, or a large chunk of them, and maybe even several components of the AOSP, and then possibly be able to have a way much more granular update system than we currently have. Heck, maybe we even do a sudo apt update, sudo apt upgrade as we do on Ubuntu one of these days. So anyway, that's just kind of like my initial thoughts here on Apex. Again, I haven't played around with it. Maybe ultimately, again, like some other stuff that's been done in the past, maybe there's a profound amount of wisdom here that evades me, and I this is a proper solution for this problem, but I think that it would be interesting to see other ways of doing this. So that's kind of like a very kind of cursory analysis of the internals as they stay now. One thing that I'll give you as a heads up, I think moving forward, say future versions of Android, the one thing that will probably be kind of like the next big thing to happen is generic kernel image, and it's not me saying it, it is actually part of some of the discussions that are ongoing. So if you go looking at the Linux Plumbers conference of this year, the Android Micro conference that I was helping organize had some talks about this, and so there's some serious efforts being put here into looking at being able to do to say the kernel what has been done to the hardware enablement in user space with the idle/treble stuff, and the idea there being that is it possible, and this is of course still to be done, to be seen. Is it possible for Google to provide a single kernel image that everybody can use, and then have the actual hardware enablement be provided as modules or additions to that, such that the kernels can continue moving forward or updated independent of the hardware vendor or the OEM or the SOC vendor actually doing any sort of effort to get their kernels up to that. So that is that's going to be interesting to follow. Again, I don't have anything to say on that other than have a look at the conference material that has been presented about this at especially the Linux Plumbers conferences. There were at least talks last year, and then this year the Android Micro conference has had some coverage of that. So if you're curious as to what's coming up there, that's what I would suggest you take a look at. And that's pretty much for me in terms of a quick look through the Android 10 internals. And again, this just barely scratches the surface. There's probably way too much more to be looked at. And at this point, I'll just open it up for questions. Again, since this is very cursory analysis, you may have questions about some stuff that I showed you, for which I have absolutely no answer, and it will just be a to be continued sort of story if you have those sorts of questions. So I'll just hang out here in a bit, see if there are some questions that come in the chat before we sign off. And otherwise, thanks for watching. And if in the future you see this video and you find some glaring issue that I've not properly addressed, or some mistake that I did, by all means, please post some comments, and we'll try to address those in the comments of the video. Yes, hope you will have more detailed follow-ups coming soon. So surely, I mean, I'll have to, I'll have time to spend I'll have to spend some time looking at some of these things in more detail. Some like Apex and so on. And if I find something interesting, I might do a follow-up video. All right, so I'll wait one more minute here, and then I'll sign off. Okay, well, thank you all, and see you guys soon.